Hello, welcome viewers to the second live session of this course, NPTEL course Phonetics and Phonology, a broad overview. So many of you have been following the lectures and taking the assignments and diligently following the course, and we hope that this is catering to your whatever requirements that you had in phonetics and phonology. And what we have to remember is that this is a broad overview. So very often we did not go to the details of many things, and the live sessions are it's an opportunity for many of you to ask those questions if you would like. However, today what I plan to do is give you an overview of the course, which is the course is called Phonetics and Phonology, a broad overview, because as I just said, we did not want to go into very many theoretical details or technical details, and give you an overview of a very broad domain which related to sounds in linguistics and also and phonetics, and we also tried to include a bit of intonation and other prosodic aspects. So today, what I would like to do is cover some of the important things that I talked about in this course, and the lectures which were there in the course, and the main concepts which we covered in each of those lectures. So let me begin by talking about the first part of the course, which is about so the first part of the course was about articulatory phonetics. So we began by talking about sounds and how they're not equivalent to spellings, which we learn as in school. So the alphabet system that we learn in school is not equivalent to the sounds that we produce. So that is a hurdle which has to be overcome when one has to study sounds. So because we are used to thinking of sounds in terms of alphabets, so there is a correlation, but often we do not find the correlation. So that is the problem of the lack of the correspondence. So now and after that we also looked at the IPA, the International Phonetic Association's symbols. So when we looked at the symbols, we realized that the IPA system has its has a way of representing. So the IPA system has a way of representing and this is the phonetic chart that we're talking about, the International Phonetic Alphabet, and this alphabet is representative of most of the languages of the world. So it is revised often to be as inclusive as possible of all the sounds of the world's languages. And notice that this is many levels. So this is the International IPA chart. Beg your pardon. So this is the IPA chart which we showed you. This has been developed by the International Phonetic Association, and this is the revised 2020 chart, which means it's revised after some time, so that the more languages we know about, we try to be as inclusive as possible of all the phonemes in the world's languages. And notice that there's not just the consonants. So we have consonants, which has all the pulmonic sounds. So we'll talk about the pulmonic egressive air system. So airstream system, which we talked about in the course, and these are the pulmonic egressive um, airstream sounds produced from the pulmonic egressive airstream. And then we also have the non-pulmonic airstream sounds, and then we have the vowel chart, and we have a few other symbols which are quite unique in the way they're produced. The voice labial velar approximant and the voice labial palatal approximants, and we tried to discuss those sounds when we discuss the sounds of the world's languages. Now, apart from that, we also have the diacritics. So the diacritics show that there are various changes, there are various subtle things that are there in sounds. For instance, a voice sound may be voiceless, and then what is actually a voice sound, and the devoicing has to be shown with a diacritic, which you see as the small circles beneath the sounds. And then voiceless sounds can be voiced. So we have these diacritics, the curly diacritic there for the voice sounds, which for the voicing of sounds which are actually voiceless. We have aspiration here. We have symbols, diacritics to show roundedness, less roundedness, advanced, retracted, and so on and so forth. So also dental, apical, laminal, and these are distinctions which we have studied in both the sounds of the world's languages, as well as when we study features in the world's languages. And then also we have in the IPA chart, we have ways of showing suprasegmentals and also tones and accents in the world's languages. So this is in a nutshell the wide variety that we come to see in the world's languages is represented by the International Phonetic Alphabet in system in this way. And the more you want to learn about different languages of the world, the more you have to rely on this alphabet system, because this gives you a very concise way of understanding all the sounds that are possible in the world's languages. So now in the course we have seen this, we have gone through this quite a bit, that to produce speech, air must flow from the lungs through the vocal tract and the vocal folds, and most of the sounds of world's languages are produced through this mechanism, and then through the vocal tract and vocal folds, and after that the vocal tract modifies the air push of the lungs, and then we have the nasal cavity, the oral cavity, etc., to modify the air which has been pushed out and give its particular shape in terms of consonant vowels. And vowel fold vibration produces voicing for some sounds, and these are the very important things which we have to consider when we are studying sounds. Voicing, the airstream mechanism, and then the various other properties that the sound might have. The lowering of the velum leads to the production of nasalized sounds. So these are some of the few characteristics of the sound of the world's languages, which we have come across in this course often, and now we are reviewing those things and reminding that these are things that we have to always remember when we are studying sounds. So the airstream mechanism, the role of the glottis, and the role of the other parts inside the vocal tract in production of the sound. So this is the airstream mechanism. And whenever we have the pulmonic air-stream mechanisms, air push or lungs, which you saw in the IPA chart, that most of the world's language, the sounds of the world's languages are produced as a result of pulmonic aggressive airstream system. And however, there are other airstream mechanisms. We have the glottalic, we have the veloric. So the glottalic produces um, the ingressives and the implosives, and then we have the veloric airstream mechanism, which produces ingressive sounds, which are clicks. And also, when we studied sounds of the world's languages, we saw how clicks are produced in the world's languages. So this shows the importance of the airstream mechanism in producing different types of sounds. And then we also saw the articulators, the different articulators. We understand now that various parts of our oral system, the vocal system that we actually use for other purposes, are also integral for producing different kinds of sounds, different kinds of contrasts in sounds. So we have the upper teeth there, the lower teeth, these are all articulators. The alveolar ridge, the hard palate, the soft palate, and the pharyngeal region, the nasal cavity, the epiglottis, the esophagus, and the trachea. So they all play a role in the production of the sounds that we have in the world's languages. Now, these are the active articulators, which actually are the articulators which can move in a certain direction to produce the articulation. We have the tongue, the lower lip, which can move, the uvula can move, the glottis can move, etc. So we have studied quite a bit about the role of the larynx, which is like a valve. It's encased in cartilage. It opens, it vibrates and gives particular shape to the sounds, or particular quality to the sounds that we produce. And this voicing that is produced as a result of the vibration of the glottis and the air which passes through vibrating larynx, it leads to voicing. So this is very important in understanding about sounds. And then we have a manner of articulation. So which we cannot probably show here. So which you have seen in the course, the movement of the tongue, the movement of the tongue towards a certain region will produce certain kinds of fricatives. You can have the lateral, the tongue in the lateral position will produce a lateral fricative. Now so these are the different places, but the manner of articulation that we are talking about here is that of the fricative. So how is a fricative produced? The fricative is not produced like a plosive, and these are very important distinctions. A plosive, as we can see here, is complete closure, whereas a fricative is not complete closure, it's a partial closure. And this is not the only difference that we have. We have slow release along with the partial closure, and that's how fricatives and stops, and for plosives or stops, along with complete closure, we have sudden release. There are other differences as well, but these two make the two of them very different consonants. And then there are other manners of articulation like approximant, where there is where the closure is the degree of closure is not as much as that of stops or fricatives, and these are like r, y, l, etc., which are the approximants across different languages. So then we have vowels, which we know that which do not need any kind of obstruction, which is marked by free airflow. So that is the fundamental difference between vowels and consonants. One has free airflow, the other does not. So the free airflow that we are talking about is important, but there are very many important things that gives particular shape to the vowels. The vowels are organized in a system of horizontal levels. So where we have levels of high and low, we have front and back, and so the extreme positions here and here and here, these are called the reference points. We attribute this cardinal vowel system to the 20th century English phonetician Daniel Jones, who showed us that a vowel can be understood in terms of representation as a system of where we have vertical and horizontal extremes, and then we can understand them as high, low, front, back, and everything in between. We have central and mid vowels arranged in these spaces. Okay. And then, apart from front, back, high, low vowels, another important quality of vowels is that of rounded, unrounded. In the cardinal vowel system of this vowel quadrangle, this is a vowel quadrangle, and in this vowel quadrangle, rounded, unrounded vowels will be shown in terms of pairs, rounded and unrounded. Okay, so we can have a front, high, rounded, unrounded vowel. We can have a back, high, rounded, unrounded vowel. So the cardinal vowels can be imagined to be articulated within this part in the mouth. So the vowel quadrangle that you just saw with the extreme referent points, which stand for the high, low, or front, back, etc., can be understood to be represented within the oral system, and you can imagine that a front vowel is produced somewhere near the front of the mouth, the back, because of the way the cavities are used for the production of these sounds. Production of these vowels, we think of them as high front and high front and high back, low front and low back. Okay. So these are the primary sets of vowels. And then we have the secondary set of vowels arranged in this vowel quadrangle. And we have discussed these different vowels, but that's the way we understand the quadrangle. That notice that in one set, the primary set, we have the front unrounded. In the secondary set, we have the front rounded. Okay. And similarly for the back, we have the back rounded, and in secondary set we have the back unrounded, and we have discussed why this is the primary set This is a secondary set because it's more unusual to have front round vowels than it is to have back rounded vowels, and it's more unusual to have back unrounded vowels than to have back rounded vowels. So proceeding now to the central set. So this is the central set, and again we'll not discuss diastole mechanisms. This is just a review. Those are the diastole mechanisms and the articulators, and we have seen the passive articulators, the active articulators, and all the relevant properties of these different articulators that are very important in understanding how one sound is different from the other sound. Okay, so again, these are we talked about manner of articulation. We skipped place of articulation. Remember, this is for consonants and not for vowels. So vowels, essentially, always keep this in mind, that when we're talking about vowels, we'll always think of the vowels in terms of the quadrangle. We'll not think about separately about is it palatal or velar or uvular, because essentially vowels have no obstruction, and that's why they have free airflow. The only way the distinct characteristics of vowels are possible is because they are because of the different cavities inside the mouth, which are producing the vowels either by lowering the jaw or by rounding the lips, or by drawing the lips back, drawing the tongue backward. So, and thereby using the different cavities inside the mouth. So this is for vowels, and place of articulation, manner of articulation, and voicing exclusively for consonants. Okay, so now when we're talking about consonants, we have these very important places: palatal, velar, uvular. And as you know, what is a place of articulation? It's a place where the obstruction happens for consonants, and that's why place of articulation is relevant only for consonants and not for vowels. So we did manner of articulation. Now, so place of articulation, manner of articulation, and voicing. So this wraps up consonant articulation for us. I'll quickly I'll quickly now go to a bit of acoustic phonetics, and then I'll also try to include a bit of phonology for you. So this was the third part of the course, the second or third part of the course, where we talked about sound waves. Okay, so what are sound waves, and how do we hear them, right? So I think we cannot use I cannot use the video here of the transverse waves, which you will see, which you can play the lecture and see that how transverse waves are different from longitudinal waves, etc. But let us now just quickly look at this diagram. It's the basic property of sound waves. Okay, it's so sound waves have a period, that is cycles of repetition. Okay, so they have to be equal though, and that's when we have periodicity. If it is non-periodic, okay, so if it is this periodicity, now what is the source of this periodicity? The source of this periodicity is the glottis, which is so important for studying sounds. So this is the glottis, which will produce the repeated vibration and produce the periodicity, and these equal cycles per second, which will give us the period, okay, is also the basis of understanding sound waves. Now, these are sinusoidal sound waves, which means these are very simple. There is only one cycle here, not so we don't have a complex sound wave here. The complex sound wave is what we find for human sounds. This is a sinusoidal sound, and therefore we have just one repeating pattern. We do not have multiple repeating patterns. So in this one repeating pattern, we can very clearly see two things: compression and rarefaction. So the compression is the region of increased pressure, which is this one, and this is the rarefaction, which is the region of decreased pressure. And this period happens in this is equal, and so again from here to here it is in the same repeating period, and that's why this is a sinusoidal sound wave. But this in essence is how we break down a periodic sound even for human speech. So so we have studied these things: transverse waves and longitudinal waves. So how transverse waves are different from longitudinal waves, and all sound waves are longitudinal waves, and you also saw that how a longitudinal wave travels in the form of compression and rarefaction, which you just saw, and we had shown this with the movement of particles moving to one position and then going back to the other position. So this is how a longitudinal sound wave would behave. And then the other important properties are maximum displacement from the equilibrium position, which is sound waves, and the extent of the variation of air pressure, so which will tell you about the amplitude. Amplitude is connected to loudness, and the more a loud sound, the amplitude will be higher. And these are the basic things that we studied in acoustic phonetics. And so we saw an example of a simple wave with a simple harmonic motion. But acoustic properties of sound waves and are, as I just said, is not one repeating pattern. We have multiple repeating patterns, which you see here in figure 7. So sorry, we have two identical sine waves here. We will have another one here with yes. So this is a typical the output spectrum with multiple repeating patterns is what we see. Now, what we see here is also the source filter theory, which is very important when we talk about acoustics. So the source filter theory, now we've just learned or we've just seen all throughout the course that very important for all periodicity is our glottis, the larynx, that which leads to the periodicity. Now it's not as if the periodicity just happens in the source, in the larynx, in the glottal region, and we just hear it as is. No, our vocal tract is like a musical instrument. Think of it as a musical instrument. It filters everything that is produced from the laryngeal source, and as a result of which, not just the source, but also the properties of our vocal tract, the filter, will produce an output, okay, which is what we hear as the sounds produced by him as a result of human speech. So this is called the source filter theory. There's a source and there's a filter, two very important components in understanding the acoustics of sounds. So when we are studying acoustic phonetics, we have to understand what are formants. So formants are regions of energy which are which are accentuated because of certain frequencies inside in our vocal tract. So those energy regions are accentuated because of the resonance inside the vocal tract. Now, why does this happen? Now, once you have periodicity, so let me just quickly. So once we have periodicity of the glottal source, it produces and we have what is called the fundamental frequency as a result of which, so our vocal tract, your vocal tract, my vocal tract, they're repeating at a certain fundamental excuse me, at a certain frequency. So this fundamental has has harmonics, which means it has resonances. This fundamental frequency has at integer multiples, it has resonances at integer multiples. So which means if your fundamental frequency is 100 hertz, then at till you will have 200, 300, 400 various harmonics of that fundamental frequency. Now, when we have formants, some of those harmonics will be highlighted by the filter that we just studied. The filter is our vocal tract. Some of those harmonics will be accentuated by the vocal tract. And that is a function of the vocal tract. It will accentuate some of the harmonics. And as a result, you will hear different vowels that's why R sounds different from E and E sounds different from U. And how we calculate those formants, the way of, this is the idealized way of, so how we actually, an algorithm will calculate the formants is slightly different, but this is the idea behind calculation of the formants. So suppose we take the vocal tract, an average vocal tract length is 17.5 centimeter, and then the three formants of this vowel schwa is calculated with this formula, and which is which is n minus 1 into c by 4l, 4l being the length of the vocal tract into 4. So this is the formula which will give you the three different formants of the vowel schwa. So its first formant is 500 hertz, second formant is 1500 hertz, third formant being 2500 hertz. And these three formants are the regions where you will see, when you see a spectrogram, you will see that it's a schwa. These three frequencies have very dense energy in the vowel. So that's because these are the frequencies in which there is energy in this vowel. Okay. So, and however, we have to remember is that now this formula is used for schwa. Not all vowels can be calculated using the same formula, because the schwa is special. The schwa is special because for the articulation of the vowel we use the most neutral the most neutral shape of the vocal tract. So whereas for the production of other vowels, we do not have such a neutral. So hence only the length of the vocal tract is enough to calculate this, the formants of this vowel. And we have more complicated ways of calculating F1. For instance, E, we have to talk about the Helmholtz resonance, and for the first formant of the vowel E, because again, as we recall, we talked about the different cavities when we have different vowels. So I have some time to talk about I have some time to talk about the phonology. So, so now phonology and phonetics. So we are talking about a broad overview of phonetics and phonology. I guess I do not need to repeat this, but phonetics is about the physical properties, and phonology, on the other hand, is about mental representations. Okay. Now, hence, there is a difference between the way we talk about more and more we see that in the literature, in the way that we conduct experiments. Phonetics and phonology come together a lot, but there is a fundamental difference, because phonology will always look for the way a sound is mentally the representation, the abstract properties, and phonetics will always be about the physical properties. So phonetics need not really bother about what is the mental representation, how we're storing a sound in our mental maps. So that's not really important in phonetics. However, that's very important in phonology. Hence, when talking about phonology, we will hypothesize rules for the way we see sounds are occurring in the phonetics, because when we're producing sounds, it's often the case that there'll be one sound will be different from the other. But phonologists will say that regardless of the fact that they're different when they produce, they can be in the mental representation, they can be the same sound. So phonetics sounds vary with the context, and phonology hypothesizes rules to characterize this variation. And the sequencing and distribution of speech sounds is important in phonology. And phonology also is interfaced with the other grammatical components, morphology, syntax, etc. And importantly, when we talk about phonology now, different from phonetics, is that important things in phonology is how are sounds different from each other? How do we make up the words in a language? Obviously, one sound has to be different from the other to make a very basic distinction between two different words, right? So that's how a pat will be different from bat, which is very, if you think about it in terms of phonetics, the difference is not so much. But in the phonology, this contrast is important because it tells you that the meaning is different just because of that contrast. Now, so what we talked about just now is conceptualized in phonology like this. So we have an abstract level, and then we have a concrete level. In the abstract level, that's how we are storing the sound in the mental representation. However, when in terms of the production, it will vary. So suppose we take an English vowel. English vowels have this property that they will be long before voiced consonants, and they'll be short before voiceless. And then we can, but it's the same vowel. It's just that it's a property of the language that one becomes long and one becomes short. But there's no need to incorporate that in the study of the phonology, because that's sort of an automatic rule. So any speaker of the language will employ that. So and similarly, various other rules like English. English also only has alveolar n, right? However, it can become dental because English also has dental fricatives. Dental fricatives. Now, if there's a dental fricative, what is actually alveolar will become dental. Now, that is what phonetics does. The presence of the phonetic properties does to sounds. It makes them change from their actual mental representation to something different in the production of speech. So hence we also talked about features and representations, and so all these mental representations are important when you're talking about phonology. The representation of sounds as formal objects, which have definite, very definite, which are definite mental entities. So that's how you see that phonetics and phonology are different. The way representation is viewed in phonology is things like feature representation. Sounds are represented in terms of features because groups of sounds behave in the same way. And also, phonetic, allophonic changes can be shown with the help of rules. Something changes to something else in this environment. X goes to Y in the environment. Z is the format for writing phonological rules. And now, when we talked about intonation, we talked about how intonation. Um, I have um, I've skipped a lot in the phonology of the world's languages which we had in the course. In the overview, we talked about morphophonology, we talked about stress, we talked about syllables, and phonotactics and morphophonological complexities, and then prosody and tone and intonation in the final part of the course. Now I'll wrap up my lecture today with how intonation makes a difference. So I have skipped a major part of phonology, and now I'm talking about intonation because that's the last part of this course on phonetics and phonology, a broad overview. So we had seen how intonation makes a difference. So remember how we played these sounds, these sentences. So what types of foods are good source of vitamins? So either the response could be legumes are a good source of vitamins, and or you can say legumes are a good source of vitamins, or you can also say legumes are a good source of vitamins. So depending on, so you can have three different ways of answering that question depending on if the question is different. But if you have what types of foods are good source of vitamins, you can say legumes are a good source of vitamins, or you can say legumes are a good source of vitamins. So uh, so when you are in intonation, what you are doing is that with the pitch and other properties, suprasegmental, what is known as suprasegmental, or prosodic properties, you could the meaning, the implied meaning could be slightly different based on where you are putting emphasis and what kind of contour you have while you're answering the question. So, and we had another sentence like I'd fly to Devonport on TWA. TWA, so if the answer is TWA doesn't fly there, they could be two different types of answers. So either they fly to Des Moines and they fly to Des Moines. So either you are sort of questioning, so when you say that TWA doesn't fly there, depending on the intonation um, of would they fly to Des Moines, you might have a simple declarative answer, or you might actually have a sort of a questioning sort of answer, and all of that makes a difference to the meaning of the sentence. And again, when there is ambiguity in a sentence, always intonation can change the meaning. So here we have a sentence where vitamins is put in bold there. So there here in the sentence, you can see the pitch contour. It steadily rises towards the end. So what does this rise mean? It means that vitamins is emphasized here. Legumes are a good source of vitamins. So it's not. So what does this mean? It means that legumes are not a good source of proteins, or maybe also a good source of proteins, but definitely a good source of vitamins. So this high pitch there, rise and fall, shows that the vitamins is emphasized there. Unlike, um, so and another important thing here to note is that the pitch contour is broken in these places. We do not have one straight pitch contour. It shows that all these different consonants are attributing their properties. This is called microprosody, and very often we ignore microprosodic effects when we're talking about intonation because they do not show us much about the intonational contour. And then, unlike legumes are a good source of vitamins, we can say legumes are a good source of vitamins, right? So we can, which means legumes are a good source of vitamins, not, for instance, wheat or rice or bread. So instead of bread, legumes are a good source of vitamins. So intonation does have a lot of adds a lot of meaning, and the pitch contour and the tune and the text and the alignment will tell you a lot about the intonation. So this rise fall that we see here, legumes are a good source of vitamins. So this is the same tune, which means a rise, it's steadily rise and then fall, same tune, but the alignment is different. The alignment shows that this rise fall is on good instead of vitamins or legumes. And again, here a rise fall, as we studied just now, it's on the vitamins. And then we have here a broad focus sentence where we're not really emphasizing just one part. Legumes are a good source of vitamins as a general declarative sentence, saying something matter of fact and not emphasizing one part of the sentence so as to give a particular meaning to that sentence. So this is just a declarative sentence, and this is called broad focus, and all the previous instances we would call them narrow focus sentences. Narrow focus sentences, these were narrow focus. This is also narrow focus. However, this is a broad focus sentence. And then finally, the tunes of the text. Okay, the tune of text will determine what kind of sentence that is. So we can have a yes/no question tune. Are legumes a good source of vitamins? So, and the answer to that question would be yes or no, depending on whether you think legumes are a good source of vitamins or not. So, yes/no question tune will be: are legumes are a good source of vitamins? So, and then there's a slow rise, and then we have yes/no questions where you can ask whether are legumes a good source of vitamins? So again, where you have showing that you can also question a part of the sentence. Now we can have, again in this sentence, we can have surprise contour tune, we can have emphatic tune. Legumes a good source of vitamins. So again, you can have a surprise tune there. You can have, or you can have a WH questions. What are good source of vitamins? Again, where the tune is different. So these are the important things when you're studying intonation, broad focus, narrow focus, alignment, text, tune, and the rise and the fall, and the contour, and where the fall is, where the rise starts. The rise starts normally at the prominent part of that sentence, and then if it's a yes/no question, rise all the way up. If it's a WH question, it's on the WH part, what or where you have the rise. And then if it's a prominence, narrow focus, then it's the part of the word which is narrowly focused. Legumes are a good source of vitamins, or legumes are a good source of vitamins. So depending on which part you're emphasizing. So this is also this can be studied in phonology as in terms of phrasing, in terms of tune text alignment, in terms of rise and falls, and very interesting studies can be carried out in terms of meaning, the correspondences with meaning, etc. also. And if you're interested, you can carry out these studies. So thank you for listening, and um, so I think there are some questions. Explain feeding, bleeding, counter feeding. Oh yeah. So when you're talking about rules, so when there are two rules, so suppose there are two rules X and Y, and the one rule is providing the environment for the application of the other rule, that is feeding. Okay. So and when you have bleeding, the second rule is taking away. Okay, if you think about it, if you just think about it in terms of abstraction, so one rule is just taking away the environment for the occurrence of this the first rule. So suppose there's a rule, let's make up two rules. So suppose there's a rule saying that if there is a if there are two voiced consonants, if there are two consonants and one is voiced, then the other will also be voiced. There's a voicing assimilation rule. But now we have a second rule which deletes consonant clusters. So suppose now we have suppose the two consonants occurring next to each other. One is a f and one is a l, and because of the presence of l, the f is definitely going to become changed to v, which is a voice counterpart. Now we have a rule saying delete, avoid CC, or delete one consonant, delete the consonant on the right, and now that takes away the environment for the occurrence of the second rule. So that's a bleeding rule. So and then we have counter feeding, which is again you have the which is of course the counter to the feeding. So you have a feeding rule, but it is countered. So and it's a feeding rule. The counter feeding rule is slightly difficult to give an example without a right example, but feeding and bleeding is the simplest way of understanding both counter feeding and counter bleeding is also. So countering the feeding and countering the bleeding. So if you understand feeding and bleeding, then it's easier to understand counter feeding and counter bleeding. And difference in type of coda consonant, long vowel or diphthong effect, syllable weight. Which among the following words have a heavy syllable? Palm, pat, pan, patch, pouch, pain, peel, peak, pack. Coda consonant, long vowel or diphthong effect. I think what you're asking is the question is about. Something you have to remember is that whether a coda consonant lends weight, syllabic weight in the language or not may be entirely language dependent. Okay, so so in English, yes, so in English we have coda consonants. So these examples I assume are from English, and in English we have both vowels and so long vowels and final consonants lend coda weight. And which among the following words have a heavy syllable? So I assume these are all with coda consonants. So because English is a language which is syllable weight, so they would all be attributing to the coda, okay, to weight. Okay. So but remember this, that this may not so not in all languages are coda consonants attributing to syllabic weight, but English is a language where we have coda consonants have weight. Okay. So I do not understand about the trapezium. I think that question is related to the vowel diagram, the vowel quadrangle. So the vowel quadrangle is of that shape. So if you consult Daniel Jones, it's because of the how front the front vowel is, and because if you think about the shape of our vocal tract, then when we produce a vowel, such a low vowel, it cannot be, even if it is front, it cannot be that much front um, as the high vowel E. So as a result, it is given that particular shape, and that's why it has a certain ratio of 4 3 to 1, and that's why the quadrangle is of that shape. Prepare for the exam, so please please listen to all the videos and go through the course materials. And features say there are elements of sounds that we can control. The elements of sounds that we can control independently. What does independent control? I think the question is not very clear. I think independent control is not about voluntary controlling. It's about languages and how they arrange features in their individual languages. So I think I really don't understand the question, but maybe there is something more. So what are bimoraic vowels? So you can have a mora. A consonant can lead to a mora. So if there are two moras, then it's bimoraic, obviously. So and if you have a vowel and a consonant in the final position, then so if you have yeah, so if you have two consonants, so you have bimoricity there, and then some things which we have not covered in this in this lecture so much is that we have super heavy syllables. We do not just have heavy syllables. There are languages which have super heavy syllables with more than 2-3 consonants in the moraic position. And then there are some languages which will lengthen the vowel also to quite a bit. So there could be super heavy syllables also. So we have not discussed those examples, but keep in mind that those kinds of languages are also there, which have very heavy syllables in the coda position. And yeah, so for the time being, for this course, we just talked about codas and heavy syllables and long vowels contributing to the mora. So no, so we produce the diagrams. No, so you will not have such questions, but keep in mind you need to know the diagrams, because you will get questions based on the diagrams, but you will not be asked to reproduce the diagrams. Okay. So I think we have come to the end of this live session. I don't see any other question here. And thank you very much for all of you who participated, and we can keep the discussion going in the following sessions. Thank you.